So this next section is about different properties of definite integrals. First one is the zero property of definite integrals, and this property says that if you take an integral from some number to itself, no matter what the function is, you will always get zero. And going back to the idea of the integral is the area between the curve and the x-axis, if the width of my interval is 0, because I'm going from, in this picture, I'm going from 2 to 2, if my width is 0, doesn't matter what my height is, my area will be 0. So it's a very fast integral to solve. Anytime you have an integral from one number to itself, don't even look at the function. That would be 0. The next one is the reversal of limits of integration. I have talked about how if your area is below the x-axis, then we call that negative for definite integrals. The other way to have a negative definite integral is to have your limits of integration kind of backwards. Normally we have our small number at the bottom and our large number at the top. But if I were doing this integral, whatever this function is, if I were doing this integral from 2 to 1, my answer would be negative whatever that area is numerically. So make sure you're looking at your limits of integration to make sure that they're in the order you're used to seeing them. If they're not, then you can just change the order of integration by changing the sign. The next rule is the constant multiple rule. That means that if I multiply my function by a constant, I can just multiply the whole integral by a constant. And the way I think of it as when you multiply your function by a constant, that's a vertical stretch of your function. And if you multiply your height by a number, then that will multiply your area by the number, because you haven't changed your width at all, you just changed your height. The other one is a good relief that if you are adding or subtracting functions inside of an integral, you can treat them just the way you want to, as separate integrals. If it's easier, you could say, okay, I'm just going to look at the integral of f of x and the integral of g of x, and then I'll just add my results together. And according to this rule, I don't need to find the integral of sine of x plus 2 minus x. I can find the integral of sine of x and 2 minus x separately and then add the result together. The last rule is the integral over adjacent intervals. What it means is that if I'm going from A to B and then from B to C, I could make my life easier by just going from A to C. So if I'm doing the integral from 1 to 2 and then the integral from 2 to 3, that's going to be equal to the integral from 1 to 3. All right, here are some examples of these kinds of problems. I have a function f and I'm telling you the area, the integrals from certain intervals on f, and I want to know the integral from -7 to 0. Well, I know that the integral from -7 to 4 of f of x is 3, and I know that the integral from -7 to -4, I know the integral from -4 to 0 of f of x dx equals -7, so then I know that this integral from -7 to 0 would be -4. The second one, the integral from 6 to 3. So first of all, my limits of integration are backwards, so I'm going to change those so that they go from 3 to 6, which is the way I like to see them, with the small number on the bottom. And then according to the constant multiple rule, I can take that 5 out in front. So I made it negative so that I could change my limits of integration around, and I took the 5 out in front. Now the integral from 3 to 6 is negative 6, so this integral would be negative 5 times negative 6, which would be 30. Number 3, we are subtracting f and g, so we can find the integral from 0 to 6 of f of x dx, and add the integral from 0 to 6, not add because it's a subtraction problem, we can subtract the integral from 0 to 6 of g of x. So from 0 to 6 would be negative 1 for f, minus for g would be negative 6, so minus negative 6 would be 5. And then the last one, I don't care what the function is, I'm doing an integral from 3 to 3, so the answer would be 0 because of the 0 property for integrals. Those are properties of definite integrals.